Oh, there you are, Christian.
Yes, I'm here this time. Yeah, sorry about that.
No worries. You want to talk about native histograms?
Yes, but honestly, yes, I actually absolutely want to talk about them, but I'd love to flip around the topics if possible. Next one would be compression, because that to me seems a bit simpler.
Okay, sure.
If that's fine. But kind of like to ask you to look at this. I just chatted in the chat this diagram. That kind of I try to put down the discussion points in bold. So the Istio 129 release by a PR I proposed received global configuration capability to enable compression on the stats. But this actually only means that the Envoy instance that listens on 15090 has HTTP compression available for its metrics. But the actual way metrics are usually fetched, that's the kind of discussion point I want to make, is via the agent, right? So the proposed pod monitor that is in the what is it, contrib or something folder for the Helm charts, actually uses the Prometheus IO annotations and stuff to set up scraping for metrics, which could also be merge metrics. So when the metrics include the application metrics, so to make it just one scrape. But to cut a long story short, the thing is, it's actually the agent that is being usually queried for metrics, which then in turn goes to Envoy, fetches the Envoy metrics. If metrics merging is wanted, fetches the app container metrics, and then sends back the metrics merged to the scrape. And there is no compression there, but this is the big lever. And there's two proposals. There's one by the mentioned Lar Auger, I say don't, what's his real name? Lars Hagen from Norway, who proposed to add another listener. That would be one, another path. That would be one way to then send the scraper via Envoy to the agent to make use of the new compression capabilities that that we added, or to add compression to the agent itself. So the HTTP server from the agent shall receive support for compression. As said, this is a 90% or more reduction in traffic, so it's a really big lever. There's quite a few fans, me or us included, to save some money on metrics transfer.
Yeah. So between the two options, I guess going to, like, I understand putting compression in the agent, so we'll come back to that one for a second, but just the other one, where you said we're going to leverage the compression feature in Envoy and have Envoy front the agent port, is that correct?
Yes, that's not my suggestion. That is what Lars suggested in one PR, but he actually made two branches. So he kind of already discussed both possibilities, and yeah, he proposed one, but yeah. So if you scroll up to the very top of this PR, you see the two proposed approaches. Those are the two approaches.
So the downside of the Envoy bootstrap routing to the agent on the telemetry endpoint is consumption of local bandwidth on the machine, right? So it's somewhat redundant. Either way, right? So the agent's going to call Envoy, or Envoy's going to call the agent, and the agent's going to call some other things, right?
Yeah.
Like we go back
scroll further down to where you were, have a second graph where the other routing is shown. Yeah, there you go. That's kind of the weird way. I hope I understood everything correctly. That's why I kind of drew the graphs to actually understand the traffic flow. Yeah, but this would be the resulting traffic flow then. So the scraping would then go via 15090, so Envoy with the new path, as you said. It would then, from Envoy go to the agent. The agent would then do the same thing it always did, including fetching metrics from Envoy again.
Right.
So it's a bit complex. Apart from potential efficiencies, mem copies and stuff, we're talking metrics in the end. It's about the expectations, which component is kind of in the lead. So if only one of the component would be active, so should it be the agent that is kind of, even if Envoy would be crashing, should the agent be available and return metrics, including maybe metrics about an Envoy being down or whatever, or is it either way? So that is kind of the discussion I wanted to make. Apart from the technical efficiency or non-efficiency of how the traffic flows, what is the actual architecture that is intended? What is the leading component that you would ask for the sidecar health or the sidecar metrics in general?
Right, and then, in the longer term, right, agent becomes a process we're less and less likely to ship over time, right, for a whole variety of reasons. So principle of these change, right, would say start with this variant, right, because this is what is already happening, and just make the agent compress, right? That's the smallest possible change.
Yes.
Did he test the okay. I mean, clearly that there's zero reason to object to just adding compression support to the agent, right? Like these change. People can obviously assess whether it's doing a good job or not, and then we can iterate from there. Is there any specific argument to favor the second option? I'm not aware of one. It adds more hops, this one.
Yes, and it changes the flow as it was before.
Yeah.
As apart from the inefficiencies of going one more hop and stuff, it's all local, and it's just metrics in the end. But yeah, it would change the way things are connected to each other. Yeah, that's
okay. So I don't know about other people, but I would clearly prefer the first one for least change, 2 for fewer hops. If we're going to make systemic dependency changes within the stack, those can trigger weird side effects and things like that. So we just got to be real careful with it. Yeah, so thumbs up for Keith. So does anybody else have an opinion one way or the other? I guess Keith and I are on the just fix the agent. I will take that as a resounding.
If I may, in one of the comments, I proposed using Klaus Post wrapper to be a bit technical here, because Lars already proposed in the branch that he has. There's no PR he made out of that, but he in the initial post he gave a link to the branch where he also added compression to the agent. I thought this could be a bit simpler by just using Klaus Post gzip, HTTP, whatever wrapper library, because he already used Klaus Post in the and in his dependencies in the agent anyway. So this is just making the HTTP be capable of compressing. So that, to me, that would be like the smallest footprint. Very, very few changes. Maybe we can even make use of the new config variable, the global config variable in the proxy config that we added in 129 to switch like the Envoy compression on and off, and also the agent compression on and off. So everybody has what they want, right? You can turn it off, but it's on by default, because it's already dependent on the accept encoding header that the scraping client sends, right? If you don't want to, or if you can't accept compression, it won't happen, right? It's about
yeah. So it's
like asking. Right?
Like the only flag control the user needs is whether to turn it off, really, right?
Right. That would be my approach. because that's the same approach we agreed on for the envoy metrics, which was an individual flag that or annotation had to be set, and it's now a global proxy config option. So why not reuse this option and just make it like a global? You want metric compressed, or you don't want them compressed, and that's it. Right? You can always override by the per pod proxy config. That's always an option, but yeah, in general, then everybody has what they want, right? You can either leave it on default as a default to offer compression, and if somebody actually wants to force it off, you can.
I've forgotten the name of the library you said. Cloud cost compress, was it?
From Klaus Post, yeah, I dropped it in the chat here. That's the.
Just feel free to add it to the doc.
Yeah.
And you said the flag is in proxy config?
Yes. I'll drop a link to the. So that's the two things. So the first is the compress, or the GZ HTTP wrapper by Klaus Post, because he already used the Klaus Post compression libraries all over the place anyway. So it's quite common. So this is just one of his helpers to apply compression to the Go HTTP server. So you don't like implement lots of stuff. You simply wrap the regular Go HTTP server, and it has support for that. So that's the first link, and the other one is the pull request to the feature that we added to 129 about enabling compression globally or disabling, for that matter. Anyway.
Yeah. Now, is the compression flag on by default?
Yes.
Like, I think. Okay, good, because there's literally no reason for compression not to be on by default for this use case.
Of course, we like to have compression, so obviously I'm going to argue that the default is the better value. But yeah, I quoted SuperQ from Prometheus and other sources where they say it's always advantageous to enable compression.
Yeah. Okay. On the compressors themselves, what are the ones that Prometheus supports? gzip, deflate, and zip?
I believe only gzip. Prometheus only supports gzip. If you go Victoria metrics and stuff, they do Z standard and broadly and whatever. So yeah, I don't know if there's an open telemetry standard for what has to be supported, but it's an HTTP kind of negotiation, right? So you either so the client sends everything that it can accept, and the server does pick any of those.
Yeah, I mean, for prep, right, gzip is not the fastest.
Yes.
Zip nowadays would be faster. So I guess what we should do is make sure that we are Prometheus improvement safe and understand which of the compressors we would prefer if Prometheus starts to support more or somebody uses something else.
Yeah, good point. So that would likely rule out this particular library, I believe, because there's only Z standard and gzip supported.
Oh, Z standard is great. Z standard is very fast.
Yeah, so those are the two that it supports.
Yeah, I think that's fine.
No broadly though, which would be one
broadly is not actually
not fast.
It's not fast, right? It's designed for low bandwidth links for mobile and web. So I think we would just prefer Z standard over gzip if both were available.
Which is, I believe, the default. So both are enabled by default if you use the library, and it will obviously follow the Q value that the client sends, which the client prefers and stuff. So it's a proper negotiation that's happening. Yeah. But I have no particular experiences with this particular library. I just thought you're already using dependencies from Klaus Post anyway for compression. This would be like a less of a leap to grab some third-party stuff to do the compression and things.
Okay.
Likely much better people to give some insights in what to use here.
Yeah. I mean, over time, we probably prefer LZ4, but that's fine. Okay. Then I think we're good. We know what to do.
Awesome. Thank you very much.
Thank you, Christian. We want to go back to your previous one, or do you want to go to the next one?
No, that would be great. I sincerely hope not to use up all your time. I don't know how big of a time slot this whole meeting usually has.
I think you have the whole meeting except for Liam, and he was going to ask about Lua. So
all right, make the most of it. Yeah, the other topic is about native histogram support. There has been an open issue by John, I believe, for quite a while. If you if you look at this one, yeah, it's quite. Let me see. Native Prometheus histogram support. It's not by John. Mostly dependent on, yeah. So he responded. Sorry. So it's from March 2024, so 2 years old. So native histograms. I picked up the idea and asked about implementing this at Envoy because that is where most of the histograms come from. And then I kind of dug into a rabbit hole because, first of all, Envoy has now added support for native histograms just recently. So it's going to be in the next release. Cool, because that is what John said is the stuff that Istio is waiting for, the capabilities that Istio is waiting for, but it got more complicated because to transport native histograms, actually only protobuf is standardized. There's work being done in the OpenTelemetry space to have a text format for native histograms.
Okay.
But it's not standardized yet. But Envoy kicked into gear and they also implemented protobuf support for their metrics. So they now have native histograms and protobuf support. Cool. So if you would scrape Envoy, you would be able to leverage this capability. But if you use the previously discussed way of asking the agent for metrics, the agent is actually the client that talks to Envoy to get the metrics. And the agent is only capable of using the textual format. So it cannot actually fetch native histograms from Envoy. And I do you one better, it also can't do that from the application. So the more applications receive native histogram support, the less and less this metrics merging like fits people because yeah, you're unable to make use of that. So that is the discussion I wanted to make, that if you mentioned that you want to get or you want to use the agent less and less, but if the capability of metrics merging is one of the core capabilities that you want to maintain, then extending support for protobuf and the capability to merge two protobuf responses from two sources would be what is needed actually.
Okay, so first, because I don't claim deep expertise in the vagaries of different OpenTelemetry and Prometheus libraries, how can the agent know whether the application supports protobuf or not?
It usually would send an accept.
It's the same mechanism, accept encoding?
Yeah, it's the same mechanism. Yep.
Or accept content type.
Yes, content type. That is how the negotiation is happening. Yeah, and then the client, then the source would be able to respond with native histograms if enabled and stuff. So yeah, it's fairly new, but it's not like just came out last week. So everybody's kind of waiting for the other component, either the sources or the scraping targets. So, but I believe Prometheus has this on in GA for quite a while, and also tools like Grafana Mimir and stuff. They gained support for native histogram. So it's and especially for the richness that Envoy on the latency graphs and everything that Istio makes out of it. This is quite an efficiency improvement that could be leveraged here.
Yes, I imagine it is. So if we wanted to, so let's say principle of least change in terms of architecture, right? We would now want the agent 1 to be able to serve protobuf as the content type.
Yes.
2, to be able to sense whether an application, right, to start accepting the content type when it scrapes other things itself. And 3, to be capable of performing a merge into the protobuf content type.
Yes.
From non-protobuf content types. So that last one, is that actually doable? So let's say there is no histogram support in the application. It won't, right? A histogram is a type of metric, right? I don't overload the metric name and say, okay, it's histogram or it's not histogram, right? It has to be unique. Okay,
yes.
So there shouldn't be a collision between non-histogram types and histogram types at merge.
No, it has to be on the source. The source presents the data differently, so you have to. This doesn't happen with the negotiation. Protobuf is required to transport it, but it's an out-of-band, I'd say, agreement or configuration that the client actually provides.
So the application doesn't support protobuf, and Envoy does. The agent's going to call Envoy and get protobuf. Going to call the application and get not protobuf, and it's going to merge right into a unified set of things. When we say merge, we mean concatenate,
which is the current implementation. If you look at the link I
okay.
Yeah.
It's not merge in the sense that they could produce the same metric and we add them together, because that would then be really problematic.
Yeah, no, that is not what's happening. So it seems to be a bit more complicated to do than just the concatenation that you would do with the metrics format.
So it would at least need to translate from the text format into the protobuf format.
Yes. But in the end, it should be a serialization format. So no matter whether you received a native histogram or not, it's just a different serialization of the same data from what I believe. I don't have all the answers yet. I simply wanted to make you aware that this is kind of the issue, and the issue got bigger than I thought it would be. Right? I initially thought, well, yeah, native histogram support, that would be cool, and then it was into Envoy, and then I figured out, oh, it's about the metrics merging that is actually the problem. And to some extent, it's also the custom metrics collection. What is it called? The plugin or the extension that produces the Istio metrics. For them to be native histograms, I believe there could be some changes required as well, but minor, right? Because it's all in Envoy, and Envoy already supports this now. So, but this might need some fiddling as well. So to have the Istio metrics, so Istio time series, also be presented as a native histogram if you want to.
Okay, let's talk compatibility. So Prometheus supports the protobuf format. Does the agent have to support output in both formats to maintain back compat with other systems that may not?
Yeah, absolutely. I totally believe that you need to have the textual formats available. You can't go all in on protobuf because you will break people's systems.
Yeah.
And I mean, if you look at the code, there's a backend negotiation, because I mean, you get a request from the scraper in to the agent. So now you start talking to the application and also to Envoy. And the question is, if I might need to do a code review again, how that actually is timed. But if you ask the application first, I believe that is how it works. So it first asks the applications for the metrics. And if the application and then it will ask the application for both formats. And the format that the application uses is, I believe, also then used to scrape Envoy, because that can do both, like the open metrics versions and some fallback regular text format text. Yeah, it's just text plain, or the open metrics format. So the various text flavors. So it does a common format matching, right? It asks the application, hey, give me some metrics. This is all I can do, and whatever the application chooses to respond with, that is also used to then query the metrics from Envoy. So that could be a way to keep this compatible, right? So only if your application does provide native histograms, Envoy will provide native histograms. That, at least, that's a bit simpler than trying to like support everything, like the most ancient applications with no native histograms, while at the same time also exposing the native histograms that Envoy brings to the table. But it could work. I mean, maybe.
So just so I understand, if the agent calls the application, and if the application can only serve a text format, right, obviously it will have no native histogram in it.
Yeah.
But Envoy does have native histogram support in it. And so our options are drop down into the lowest common format and elide the native histograms, or upconvert the application ones into the protobuf format so that we can serve latency histograms out of Envoy. And we like using latency histograms, one, because they're denser and therefore more wire efficient, and also they're better, right? They allow us to do
Yes, they're more
percentiles much
precise.
more accurate.
Yeah.
So they're a win. In the agent today, the concatenation, right? So then the question is performance, right? What is the cost of upconverting into the protobuf format if the application can only serve in the text format? Because if that's prohibitively expensive, right? So let's, if the concatenation scheme is I just take the body of the application, right? I write it out. I call Envoy in the same format and I write it out, right? So I never parse. Right, this all boils down to whether the agent is parsing the application response or not. If it's parsing
But
it,
I just dropped the exact line in the code that does that. Yeah, it's exactly working as we expect. Yeah, it will ask the application first, and whatever format the application responds with is then used to use the same format to only have to do a concatenation. There's no real mangling with the data. It's just, as you said, it's just concatenated. So it's pretty simple.
okay, so.
But at the same time, if you look at the changes that the people at Envoy implemented, they actually have a different library that they use for instrumenting or collecting the metrics internally, and they at scrape time they actually serialize into the format that is required. So, I mean, it's a bit of a memory footprint, but it's just kilobytes in a sense. So it's not like terrible. It's just a serialization conversion.
Yeah, I'm not worried about Envoy, right? I'm worried about losing the latency histograms because the application had a degenerate format. But yes, the problem we're saying is because the agent doesn't parse, if we were to add parsing to upconvert into the protobuf format, it would add significant cost. Or we don't know.
That's my question. That's why I was brought. That's why I brought the Envoy implementation up, because they do upconversion, or they convert on at scrape time to the required format. So if the client asks for protobuf, it will serialize down the metrics into protobuf, including native histograms. So they do all this at scrape time. So it has to be performant enough. In a way, and maybe there's libraries that can do that, right? There's the Prometheus libraries and OpenTelemetry libraries that maybe allow for a single. There's the registry usually where you maintain different time series and values and stuff, but maybe there's also helper libraries that you can simply use to, as you said, upconvert or concatenate in that sense, that concatenate the data, not just the way the payload is presented.
Okay. All right. So we clearly need a cost comparison between these two things. I don't think we can make, or we need a cost comparison to say always upconvert to protobuf. right? If we want to make that decision, which we'd like to make, I think, then we just need to know the overhead. Like if it's going to blow CPU loads out of the water, right, then we need to know that. And then I guess that would probably have to be flag controlled initially so we could get some user feedback about trying it. I think those are the two big things we would need to know. So obviously flag support, right? So we could add a feature to like upconvert to protobuf for latency histograms. And we need a cost comparison CPU and mem, right, Keith?
But to be fair, we already fetch both metrics and then concatenate the memory. So maybe there's a way to make.
Well, when you say fetch, like it's one thing to fetch a blob of text into a contiguous like memory, like just a string, and it's a whole other thing to parse it into like 10,000 objects.
True, yeah, absolutely. I just was just responding to Keith's argument about the memory footprint, right? So the data is already in memory in that sense, but yeah, you're correct. If you parse the data and you have to re-serialize that, yeah, question is, can you do that efficiently on a memory footprint basis? And especially with the number of sidecars that you have, any megabyte you save is like 100-fold memory used, because in big clusters we run hundreds of sidecars. Each of them had to do that, right? So it's per instance, per pod that has a sidecar that this memory has to be there for the metric scraping.
I mean, Christian, obviously we're willing. Like obviously making it a default off flag, right? That's a no-brainer, right? We can absolutely do that. Start supporting protobuf the format, support the accept content type, right? That's all dynamically negotiated. That all works great. To flip the flag to default on, right? We need now the admin can control it, right? They can always say, right, don't scrape in protobuf. Or is there a control like that in Prometheus and the other systems? That is available, or is it always dynamic?
Yeah.
All right. I think then the only problem is if we turned it on and people had said prefer protobuf, but they were still getting plain text, and then it happened, right? They may get a disruption and they might complain. So I don't think we can get past the testing and/or the flag that we have to implement. Do you feel willing to take that on and to come back with a kind of very basic cost assessment for some reasonable scenario, and to the flag implementation, plus obviously the support to actually make the thing work in the first place? Is that something you're volunteering to do, or?
I'd gladly support this, but like doing the whole thing on it's not like I work for a consultancy company, so we were doing that on customers' time. So for the compression, yes, if Lars doesn't like continue work on the PR, that I can absolutely argue. But for the bigger change, because it's not just the time invested in a short time span, it's over a longer period of time, because this is like a big feature, not just the change itself, but testing it and then taking in feedback. And so yeah, as I said, I didn't bring it up because I didn't believe this is a good idea, and I gladly invest some more time, but like completely owning the thing, likely not.
Do we have some, aside from the obvious value of histograms, their fidelity, their improvement in metrics, do we have some rough idea of the bandwidth saving using protobuf? Obviously, if we move to compression, right, the bandwidth differential between protobuf and text is probably pretty marginal, but it's probably still real.
It's what I read. Yeah, I would need to look through the various comments I made on various issues, but yes, there's even an advantage if you use protobuf, which can be compressed quite good as well. But yeah, even switching from compressed text to protobuf, there's more bandwidth to be saved, less of a percentage then compared to compressing or having uncompressed text to compressed text. But yeah, yeah. But in the end, this is the only way to transport native histograms, which in themselves already smaller, right?
Yes. Okay. Do we have a tracking issue for this? We do have the one John created. Okay. Do you mind summarizing our discussion here and putting it in the issue that John opened up?
I can. The question is there anything, not saying I already said everything that we just talked about. If you look into the issue, I already
So
dropped
basically,
a few.
the TOC's opinion, right, based on the discussion we've had, which is
Yes.
this is fine. It requires work. It requires performance testing, and it requires a flag.
Yeah, absolutely. I'll drop that. Yeah.
And also requires work for ambient too, right? Because we don't want to just add this to sidecar and not work for ambient.
Yes.
Should you kind of fill me in on what's the difference between fetching metrics via so there's metrics that are fetched from the ambient instances, right?
There's no agent.
Proxy. There's no agent, yes, but so where the
like
metrics
Z-tunnel can be updated to support protobuf and the plain text format.
Right. Good point then.
Like just like Envoy had to be updated to support it, Z-tunnel won't have to be updated to do a native histogram.
Yeah, also, I'm not sure if there's additional complexity with Waypoint could support multiple services, while Sidecar, you only serve like one particular pod on deployment for that particular.
That should only affect the dimensions of the metric itself, not the actual metric schema.
It's actually a bit simpler too for waypoints because there's no merging.
Yeah.
So yeah, pretty sure there's no merging. Yeah, I don't think so.
This might actually be easier in ambient.
I was going to say that would be a good starting point, right? To be able to present your own metrics in protobuf. But this is not like much of a feature. Just using the serialization format protobuf. The heavy lifting is all in the merging and.
Yeah, because if there's no merging in ambient of any kind.
Okay, I didn't realize they don't support application merging of the proxy metrics. Okay, I agree. That might be simpler in ambient.
Yeah, it might be much easier in ambient actually. I don't know. Somebody look, see if Z-tunnel already supports the protobuf format. It might.
If it does, then the only thing would be adding a switch to enable native histograms, right? For those. So because the first requirement is being able to transport stuff in protobuf format, and then you at that point you have the capability to enable native histograms, which the whole issue is all about. To be able, the question is if there's rich histograms in the waypoint and ambient proxies anyway. So because it only makes sense for data sources that have rich histograms and would benefit from presenting them natively, right?
Yeah, we need to check. If the library is like, okay, if I'm not serving protobuf, I'm not serving histograms. I guess the only question there, like, so let's say I have a legacy histogram, right? Sorry, a legacy latency metric and a latency histogram metric. Do I serve both? Just like, because I can serve both in protobuf, or do I just serve one of them in protobuf? Right, so because they have to be called different things. Or is that an intrinsic feature where they deal with the aliasing internally in the protocol?
From what I know, usually the sources or the applications that present the metrics have a switch. So either they present native histograms or they don't.
But they can have the same name. It's an output format. It's not a renaming. And the ingestion side detects, is this a histogram or not? So people don't have to go update all of their charts because we turned on native histograms and all their metrics changed in.
No, you use the libraries like you would, like the Prometheus library that you use to instrument your code, right? And you add calls to a histogram library, and this or a histogram module inside this library. And if you switch on present histograms as native, then it will present them as such.
Okay,
right?
so that should be fine then. Yeah. Right, so there's no renaming of presented metrics required.
That's a big one. I'm quite happy that we flipped around the two topics.
Yeah.
That
okay.
So because lots of work, right? Great potential, but lots of work.
So you're in a consulting shop working with a client. Are they sidecars or ambient?
Sidecars.
Okay.
Yeah. And it's quite a big install, so it's not easy. I would have loved to say, yeah, let's go to ambient, but yeah, it's lots of moving parts, lots of parties involved. So it's not about
yeah. No, because you just
we've been pursuing this a while already. So
yeah, if it's much easier in ambient, right, it might happen in ambient, and then it might take a while to get
there's no metrics merging, right? Then the whole feature is simply not there, right?
Right.
Or not required. So you can do with the applications as you please.
Okay. There's a to-do in the TSC. Where you just do in ambient, or also backport for additional work. Okay. How about we give Liam a little time now? I think there's 12 minutes left, and then we can go back to yours on EWMA. Liam, take it away.
Sure. Yeah, it was just a heads up for, I think I've addressed all the comments on the design doc for the Lua-filled stuff. I've got draft implementations, but this is the first major feature I've contributed in about 7 years. So I'm very rusty on the code base. Pretty much all of it's been rewritten probably in that 7 years time. So it might be, it's a like 4,500 line PR. A lot of it's tests in fairness, but it might be worth if someone could buddy up with me on it and just kind of work together on going through that type of stuff, just so we can get it over the line. I'm happy to bike shed on like API design and that type of stuff and ordering of stuff, but yeah, that's kind of where it's at. I can start a thread in contributors if that helps.
That's probably a good idea.
Yeah. Okay.
Anyone here want to volunteer to be Liam's co-pilot?
I don't want to just dump a 4,500 line PR, and it's probably better for me to walk through it in a meeting room or something, right?
I can try to take a look.
Okay. Thanks.
Thank you, Stephen. And I guess a general PSA to get more eyes on the design doc again, just for next round.
Yep.
Yep. Good.
Happy to bike shed the name because I know that was one of the main things. But I did ask if anyone had a better name for the API, then they can come up with one, and no one had one. So we're going with what's currently there.
Be careful what you ask for twice. Okay. Christian, following up on EWMA.
Yes, I was quite amazed that somebody else mentioned this last meeting, because we've been looking into that. I've proposed the PR to add this admittedly contrib load balancer module in Envoy to the Istio proxy, which is now in 129. I already found a little bug that causes sec faults. Don't worry, it's not gonna crash if you don't use it. It's actually in this contrib, not just because it's built in, we have to actively use it. But we are big fans. I opened a PR. I just wanted to make you aware that from what I've found out, it at some point might require some not refactoring, but some renovations of how the clusters are configured. That would be awesome if somebody more knowledgeable than me would look into this, because we're quite keen, as obviously other people are as well, to get some more adaptiveness in the whole thing. For the customer I'm talking about, we're actually handling quite a large number of connections and high RPS. That's why we're looking into adaptive concurrency, the overload protection capabilities. So you see me all over those features, because that is actually what we feel is a bit lacking on the gateway capabilities. And this load balancing capability would be awesome to be able to run stuff at a high utilization without running into latency spikes and stuff. Yeah, that's it. Actually, I just wanted to kind of get some attention.
So just on your use case, right? Like obviously, the more traffic goes through a proxy, the more valuable like an algorithmic load balancer like peak EWMA becomes. So you're more concerned about the gateway use case here than the sidecar use case.
Yes, obviously it would be, because it seems to be a small footprint. It could be all gain also for the sidecars, especially if you use cross AZ, where you have like an added baseline latency just because you cross an availability zone. All of that could be simpler. That's the case that Roblak, the actual author of the module, made, that you can leave out many of the complexities that you usually would do in configuration if you just look at the latency, right? Because the lowest latency is usually where you want to go. But yes, we are mostly looking at the gateway use case to answer your question.
Yeah, so just to contrast that for people, like the default load balancing mode today, in at least some aspects of Istio, is locality aware load balancing, where we rely on like region, zone, subzone labeling, right, and proximity to the caller's region, zone, and subzone labels. I believe the default load balancing algorithm is least request within the locality bucket.
Yes.
Which is not nearly as good as EWMA. But for small buckets, they're probably locality aware load balancing with small bucket matches, right? There's not a lot to be gained by switching the small bucket match for the locality to EWMA, since you're already hitting a locality match, right? Now you're just really going to see non-locality effects, like one application is running a garbage collection cycle or is slow or stuff like that. If you don't want all the complexity of locality aware load balancing, EWMA is a big win, right? Because it will mostly pick endpoints, assuming all endpoints respond in reasonable time horizons at the backend side, based on their network locality over time, which will approximate the behavior of locality aware load balancing, but not guarantee it, right? Because it's left to sample.
Yes,
right?
and
like it's a probabilistic approach.
Yeah, another example of the advantages if you have like a heterogenic infrastructure, right? Just the AZ stuff, but if you
different compute types.
Different compute types, spot instances, various cloud noise or noisy neighbors that you brought in yourself and stuff, then it's really helping, because you're only looking at the ideal by the regular like strictly configured locality observing load balancing scheme. You're looking at your optimal case if you want, right? And yeah, we found that having this, we tested this in a different scenario with Envoy, and we found this quite helpful to accommodate for.
Have you run a comparison between locality aware load balancing with least request in the bucket versus peak EWMA for load distribution affinity zone by zone? Because that would be the thing. One of the things like I hear from the customers we have here at Solo is like, I want guarantees that I don't go across AZ unless the endpoint is 100% unavailable in the same zone.
Yeah.
Because I'm super sensitive to transit.
Algorithm to be smarter at the edge, right? And when this stuff happens, yeah. Same question for us. Obviously, come back to the compression of metrics. We want to save money on cross zone traffic, and we've looked at all the locality respecting configuration switches, you have either the traffic distribution switches from Kubernetes that you can now use, or the Istio specific configuration using like AZ awareness and stuff, and then running all on peak EWA. Yeah, and we found this actually is working well enough, and it's also reducing the problems if there's like a hotspot sometimes, right? When you at this point you want to use all your capabilities and maintain low latency, even though that would potentially mean you're going a bit more across AZ. But in the default case, so it works for both cases, right? In the default case, it should work, but they're complementary, right? You can actually, as you said, you can run different buckets if you want, right?
Yes. So I guess I think what would be useful, not code, is a case study where you compared. Okay, like no locality where load balancing peak EWMA is on. Locality where load balancing peak or not peak is on doesn't really matter. What is the zonal affinity property, and how the customer perceived the relative cost differential between those two things? Because I agree, simpler is better, right? And in aggregate, probably peak EWMA across the entire universe of endpoints produces a more reliable system than locality where load balancing plus peak EWMA in the locality bucket, because it will deal with more pathological situations more easily.
Yeah, that's
but
better said than I could.
Persuade,
yeah, exactly. That's the point. Yeah.
Persuade people that this is actually the right thing to do, and to do that you need case studies, because otherwise they're like, no, unless somebody else is doing this, or they're not willing to put the time and effort in, which obviously you're a client and you are, then it's hard for us as a project to make a recommendation. Is like, hey, we're just going to switch the default load balancing to peak EWMA for everything, which might actually be the best thing to do for every single one of our customers, by the way.
I wouldn't go that far.
Yeah, I know.
That would be more than I was afraid to.
I'm being slightly hyperbolic for a reason.
But yeah, the point I'm trying to make is make this more approachable with less side effects, because currently the configuration can be achieved by using an Envoy filter, but it has side effects. That's the issue. That's the comment I wrote in the issue. It's not about having this like a first class load balancing algorithm that you can select. I gladly use for the case study, or even for a production workload, I simply inject a different value. That no problem. But I already have side effects because Istio is using the old LB low policy and common LB option values and stuff. And there's some issues that Envoy doesn't accept the configuration in all cases. So I found out that if I use the traffic distribution setting in Kubernetes, that is then resulting in an invalid configuration. So and those kind of side effects you can go with into production, because as the operator of the mesh, what to do and what not to do, but do all users know, right? So somebody plays around with a setting, and all of a sudden you have an invalid Envoy configuration for the whole mesh on the gateway, and it doesn't run anymore. And that, it's hard to argue. So that would be awesome if we could in some way stabilize this way, right? So
yeah, I mean, like we could add first class API support to destination rule. Right, that is a thing that
that'd be awesome. Yeah, I'm just saying it's presented differently. It's a load balancing policy. It's a different configuration object for that is to be used in current style Envoy configuration. And that has to change, because then it's only, as you said, a simple addition on the supported values. And that would be pretty easy.
So we can take a look at that. Could you open up? Oh, there is an issue. Yeah, never mind. Yeah. You opened it. So just again, capture the notes from what we discussed here, and then as a think about whether you would be willing to be the publisher for a case study in the Istio blog.
Yeah, I'll think about it if we can get this stable in a way that we can, but apart from the risk of running this algo code, but if we can reduce the risk of wrecking the configuration capability of the whole mesh by mangling some Envoy filters into the load balancing configuration that are not compatible with all the settings, then yeah. And
Does somebody want to volunteer maybe to do a prototype implementation of adding this to destination rule? It's totally fine if nobody puts their hand up, but that
I can
I think.
I can see if I can find somebody on our side.
Okay. Yeah, I think this will be a large common good. Daniel, do you just want to tag yourself in a doc comment here?
If you could, I'm outside at the moment. I don't have access to the doc.
Okay, so what's your email?
dgrim@redhat.com.
Oh, yeah, I know. At rh.com or redhack.com?
Redhat.com.
Okay. All right, I send it to you. Thank you.
Thank you.
Okay, I think we are out of time and out of topics. Thank you for a full meeting, Christian. And
well, thank you for all the time that you yeah, offered to spend on the stuff I brought. Kind of list got longer, and yeah, thank you very much for all your time.
we love people doing things for real users who are doing stuff at scale, so we'll make them happy. Okay.
All right.
Thanks, everyone.
Bye, everyone.
Thank you. Bye.